responsible for increase in the length of internodes. Length of the internodes increases because of activities of these intercalary systems. What happens is here cells of the intercalary systems keep on dividing and re-dividing. What happens when the new cells are produced and these new cells are added to the free existing cells which are already present there in the internode? By the formation and addition of these new cells, growth in length of the internode takes place. This growth in length of the internode is also considered as linear growth, because what happens when all these internodes are going to increase in their length? Definitely length of the stem increases. Okay, increase in the length is treated as linear growth. Consider the third category of meristems, lateral meristems. They are usually present on the lateral sides of the old stem and root. The cells of this lateral meristem, they keeps on dividing and adding the cells in the lateral plane. Okay, just imagine when on the lateral sides of the stem and root is being continuously added with the new cells. What happens is, with the addition of these new cells on the lateral sides, definitely the thickness of the stem or root increases. Here, increase in the length never happens, because new cells are added on the lateral sides. When the new cells are added on the lateral sides, definitely what happens is growth in girth or growth in thickness of the plant mold occurs. That growth in girth of the root or the stem takes place by the activity of lateral meristem. Okay, this is with reference to the kinds of meristem which we classify on the basis of position in the plant body. There is also second basis of classification present there. We can categorize meristems based on origin in the plant. Means when they are exactly originated, whether they are there in the plant since the birth of that plant, or they are formed at the later stage, they originated at the later stage. Based on this, we categorize meristems into two types. The very first kind of meristems are usually referred as primary meristems. The second type of meristems are called as secondary meristems. Primary meristems. The name itself suggests primary is first. First going school. Early going school. Usually referred as primary. Primary meristems means these are the meristems which are first formed, which are originated in the beginning. Suppose, say for example, if you look into the embryo, okay, this embryo is usually having what you call as the parts like pleurum, even the parts like radicle, say for example. This entire embryo, it is usually made up of the immature cells. The immature cells which are going to construct a tissue. You know what is that tissue? That tissue is supposed to be the meristem. These are the embryonic cells, but they are meristematic in nature. What happens is, when the plumule starts growing, it grows and later it gets differentiated into the shoot system. At the time of differentiation, it produces the parts like stem, leaves and other parts. Like that, the radicle, even it too, start growing, start differentiating into what we call as the root system. Roots are going to be organized by the radicle. In the very early stages of the plant growth, you find only the meristematic tissue. But later what happens is, living at the places, stem apex and the root apex, the remaining parts, the permanent tissues are going to be produced. Let's say, for example, here, you may find the tissues like xylem, phloem, parenchyma, collenchyma, etc. Like that, leaving the root apex. The rest of the other portions, you may find what you call as the permanent tissues. But what about these tissues that they are remaining there at the apex region of the stem and root? They are the tissues derived from the embryos. They are present since the origin of the plant. That's why we consider these meristems as primary meristems. They are the meristems which are there in the plant body since its origin. Okay. And usually primary meristems are responsible for linear growth of the plant body. Remember, linear growth means growth in length. Growth in length of the shoot, growth in length of the root, that we consider it as linear growth. What about secondary meristem? If you look into the secondary meristem, the name suggests secondary. It's later. Secondary school, it's later going school. After the completion of education there in the primary school, we move over to the secondary school. Later going school. Secondary meristems. Later formed meristems. When the plant becomes old, yes, this plant keeps on growing, what happens? When it keeps on growing, not only the length of the plant increases, remember, A1, the girth of the plant body also increases. Suppose if you consider this as a stem, this as a root. What happens here is the girth of the stem increases, the girth of the root increases. This increase in the girth of the plant body takes place by the activity of a meristem. That meristem we consider as the lateral meristem. But based on the origin, we consider it as the secondary meristem. Because in a very youngest plant body, if you consider, this meristem was not present. You will find only the primary meristems and you will find only the permanent tissues. What happens is, after some time, there is a process that is going to occur. We call that process as de-differentiation. De-differentiation means it is reversal of the differentiation. Usually there is a process. We call it as differentiation. What does it mean by that? Differentiation. In the process of differentiation, what happens is transformation of meristematic cells into permanent cell stages. Assume that these are supposed to be the meristematic cells. Assume these are the meristematic cells. These meristematic cells, they undergo differentiation. Means their structure may change, their shape may change, cell wall nature may change, the functional status may change. Okay. Because of that differentiation, they get differentiated into what you call as the permanent cells. And they are going to produce the permanent tissue. It may be one of the permanent tissue, maybe parallel. This process of changing the meristematic cells into permanent cells is usually called as differentiation. De-differentiation means a reversal of the differentiation. Again, what happens is these permanent cells, they undergo a change. They undergo transformation in the structure as well as functional status. By means of that transformation, they may change themselves into meristematic cells. These are supposed to be the meristematic cells which are going to be formed. How they are formed? They are formed by the transformation of permanent cells into meristematic cells. Here, transformation of these permanent cells into the meristematic cells is usually called as de-differentiation. It is a reversal of differentiation. Usually in the differentiation, meristematic cell changes into permanent cells. But in the de-differentiation, permanent cells changes into meristematic cells. Assume that here already in the older region of the stem and root. Assume this is the old part of the stem and root. Okay. In this old part of the stem and root, already some permanent cells may be present. Assume maybe the parenchyma cells, maybe the parenchyma cells, which are permanent cells. But here, these cells undergo transformation, particularly in this particular segment. The permanent cells that are present undergo a change. They undergo a change. By that change, they are going to produce the meristematic cells. Even here also permanent cells that are present earlier, they may get changed, and by that change they are going to produce the meristematic cells. Once these meristematic cells are going to be produced, they form a tissue. We refer to this tissue as secondary meristem. Since it is not present earlier, in the place of the secondary meristem, earlier there are permanent cells present. Remember, there are permanent cells present, permanent tissues present. Okay, the cells of these permanent tissue, by undergoing de-differentiation process, they form the meristematic cells, which led to the origin of secondary meristems. So, secondary meristem is a later form of meristem that is going to be produced by the de-differentiation of permanent cells. And this secondary meristem is usually responsible for what? Look at this. It is usually lateral in position. Even you can call this also as lateral meristem based on the position. Okay, this meristem is keep on adding new cells on the lateral sides of the stem, on the lateral sides of the root. You may be knowing well that when the new cells are formed and they are added to the lateral sides, what happens? Because of their formation and addition of the lateral sides, continuously growth of the stem, growth of the root occurs on the lateral sides. Lateral growth of the stem and root occurs. Because of that lateral growth, thickness of the stem and root increases. We call this increase in the thickness of the stem or root as growth in thickness. We also call it as growth in thickness. Growth in thickness usually happens by the secondary meristems. Okay. With this basic information, you come to know that what are meristems, where these meristems are located, and how one could characterize the meristems based on the characters. What are the different important characters are there in the meristem. After that, even we also had the discussion about the classification of the meristems. Okay, how one could classify the meristems based on the position, based on the position. Suppose if you have any doubts, we can clarify your doubts at the time of June discussion class, which we are going to conduct either on Tuesday or on Thursday. We are going to intimate to you, and with that intimation you have to log in, and you can have a very free discussion if you have any doubts with reference to the topics that I have covered. Okay, thank you.